Generally, conferences are more singularly focused. You'll have more brain-specific conferences and then conversely more spine conferences. But I think the SBMT has done an outstanding job of merging the two.
The uniqueness of this organization is the bringing together of diverse individuals working in all different fields. You'll see materials scientists and physicists and economists, as well as the neurologists and neurosurgeons, neuropsychologists, radiologists, all these different people brought together in one space, in one venue. This is what's unique.
It's an incredible organization. I've come every year that I've been able to, and the posters you learn from, the people you learn from, and Babak's vision for what he wants to accomplish in the future is extraordinary.
Our goal is to create an environment that fosters collaboration. We wanted new ideas, we want out-of-the-box solutions, really break boundaries around the treatment of our patients with neurological disease. So the Society of Brain Mapping and Therapeutics is the platform that can help that to happen.
Okay, hello. Can you hear me? Thank you very much for your invitation. Thank you, Dr. Varzagar and Dr. Farhidwash and yes, Dr. Also Dr. Fatemi for your wonderful support, introduction, and of course, invitation. So today I'm gonna quickly present to you my presentation on neurotechnology. So if you could allow me to share the screen, that would be great. So let me see if I can, there we go. All right, great. So I'm going to start from the beginning for my presentation here, and I can share this with you. All right. All right. So today's talk will be really focused on neurotechnology from nanomedicine, neurophotonics, and nanobioelectronic to neuroscience policy. So together we will walk through the future of technology that is emerging, which will impact our lives. And so this disclosure that I founded this organization, the company called Smart Microscopy, to address intraoperative brain mapping. Just let me know if you can hear the video here. So this is an intraoperative brain mapping of a brain tumor in the skull base nearby the aqueduct, the skull base. Yeah, it's very difficult to actually pinpoint the tumors because the navigation systems cannot pinpoint to them, and unfortunately we have to neuroanatomically find these tumors. So the smart microscopy's strategies to actually use neurophotonic to detect these tumors. So the objective of today's talk will be focused on what's the role of Brain Mapping Foundation, Society for Brain Mapping and Therapeutics, and Brain Technology Innovation Park, and their future directions, as well as what are the definitions such as brain mapping and neurotechnology, what are the examples of it, how new technologies can help applications and outcomes of stem cell therapy or cellular therapy in general, and what should be the future directions of research and development in this area. So the mission of the Society for Brain Mapping and Therapeutics is really to improve the diagnosis, treatment, and rehabilitations of patients afflicted with neurological disorders. And our approach is multidisciplinary and in collaboration with the government agencies, patient advocacy groups, and educational institutions and private sectors, as well as philanthropic organizations and individuals. So just to give you an example here, we defined a brain mapping as like a Google map. You get a snapshot of Earth, that's your MRI, you zoom down on streets, that's your functional MRI, you zoom down on the roads, that diffusion tensor imaging, and you see the cars on the road. Those are cells, people in the cars, they are subcellular structures. So anything from MRI to subcellular structure, anything from basically Earth to people is considered brain mapping. You basically map the human brain from macro to micro. So I have a short video here. I'm not sure if I can use this. Well, that's not working. So technical difficulty, but I wanted to show you a kind of an image of how we can zoom in to the brain from the MRI all the way to the cellular level. So the second definition that is very important is nanoneuroscience. The third one is nanoneurosurgery, and the fourth is nanobioelectronics. So application of nanotechnology in neuroscience is called nanoneuroscience. The therapeutic application of nanotechnology, which could enhance neurosurgical treatment, is called nanoneurosurgery. And integration of nanotechnology with device and medical imaging called nanobioelectronic. The other definition that is very important here is neurotechnology in general, which I believe it's a technology that could help us understand the brain and or interface with it for the day-to-day activities and health. So I'll get into all this emerging technologies and describe them to you. Let me see if I can, if I can take this aside. Okay. So the Society for Brain Mapping and Therapeutics annually holds conventions as medical associations, and these are the pictures of the past conventions, and we have been recognized by Mayor of Los Angeles here for our contribution to the local and the California economy. So the outcome of these conventions come in the form of publications. So we have, as Dr. Vazagad mentioned, we have 3 prestigious journals in neuroimage. We had a PLOS One special issue on neurophotonics with SPIE, but also we introduced 2 new inaugural textbooks. What does that mean? That means we actually generated a new knowledge out of these conventions. So basically, the first textbook of nanoneurosurgery, which was also presented to President Obama, and he thanked me for my contribution to science and for the gift. And the second one is a neurophotonics and brain mapping, and you will see what we are doing in that regard. On the policy side, we are very active, as Dr. Vazgar mentioned. I've been at the Australian Parliament, started the Australian Brain Initiative, the Canadian Parliament, started the Canadian Brain Initiative. We started IEEE. Those of you who are engineers know IEEE organization. We started IEEE Brain, and worked with even Trump administration at that time to with the Undersecretary for Commerce to see if we could, build bridge between the Democrats, Congressman Ted Lieu, and Commerce at that time to fast track therapeutics. We are very active with the U.S. military and the White House here. We are at the White House, and of course, I had an honor to present an award to Stephen Hawkins. So we have a short video here about our policy forums, which I would like to show you.
In the last 9 years, we have held congressional briefing for U.S. Congress. This organization was one of the main organizations which formulated and executed President Obama's Brain Initiative. We have been very active in neuroscience policy and innovation.
What's needed is commitment by the scientific community to engage the public and to engage politicians, because the public may not be aware of the promise, the economic promise and the scientific promise, the promise to make our lives better, the promise to cure diseases. Politicians, on the other hand, have a lot of people pulling at strings, and if the scientists don't engage them, then they're not going to be feeling necessary to engage them back, because there's so many other interests involved. So I think if scientists will get involved in the political process by participating in fly-ins once a year, or by meeting with politicians in their offices regularly.
Congressmen were very receptive. They're there to help their constituents. Traumatic brain injury and PTSD are something that they recognize. And so by lobbying them and bringing in the best of the best that Dr. Kateb does, fosters this entire field, helps coordinate it, helps make it grow.
So when you, as an innovator, an entrepreneur, surgeon, try to move the needle and advance a certain aspect of the field, you eventually will run into traditional or well-established treatment guidelines and policies. So having the ability with the backwind of an organization to innovate that and implement it and spell it out in a way where it comes across as professional, backed up by clinical evidence that's high grade, that's really exciting to be able to do that.
Nothing really happens until you have the policy part of it. For any really mature organization, policy and how you advocate in the United States and Washington, D.C. is really important part of how we're going to get these better treatments.
It's a long way to change concepts of people and make them understand. And we are trying to have Congress pass a bill if possible.
And so we engage and collaborate with several different levels of the government. Congressman Rowe was here yesterday in an excellent speech. He's a big pusher of healthcare policy.
Thank you to Babak, Dr. Babak, for his incredible vision and leadership. I appreciate the recognition for my work on Endless Frontiers. Endless Frontiers is legislation that has passed the Senate 68-32. We will pass it in the House this fall, and it will mark the greatest increase in science and technology investment this federal government has made since the 1960s, $100 billion of increased investment.
So I think in terms of integrating government and trying to push forward neuroscience, collaborative efforts with the government and also international organizations is going to continue to be the mission and motivation for this organization.
It's very important to have an educated policymaker in your district or policymakers in general who make policies based on science, in our case, neuroscience.
Be engaged, share your stories every chance you get. And don't be shy about expressing your needs and concerns. Nobody else is. How we make decisions, communicate, and process information is a vital part of this new frontier. I look forward to exploring it with you together.
So as you can see, we are very active on national policy, on the global policy. We started the G20 summits, Neuroscience 20. These are some of the pictures going back to 2015, which we were part of the Obama's delegation to Turkey, and 2016 the same in China, and 17 we were in Germany, and 2018 we were with the President of the European Union discussing the cost of neurological disorders to the world economy. So for instance, if dementia was a country, it would be number 18 in global GDP. So it's very important for us to pay attention to the cost of neurological disorders and neuropsychiatric disorders. And by year 2035, that cost will be north of $14 trillion. So with that said, we published a series of papers. One is coming up, but the earlier one focused on creation of formulation of national data repository and analysis for neuroscience, creation of national network of brain procurement, allocation and banking, establishment of global alliance for nanobioelectronics in brain mapping and therapeutic, and facilitating rapid introductions of diagnostics and therapeutics. So as part of this effort, we started a $1 billion initiative under Biden administration, which is called Brain Technology Innovation Park, which I have a short video here for it.
We have an initiative called Brain Technology Innovation Park. We are going to construct a new biotechnology park in Los Angeles.
Brain Technology Innovation Park is a special type of incubator. What an incubator does is it takes ideas and it brings them to market faster and at lower cost.
Obviously, it's a very large investment. It would need tremendous support both from the state of California and from the federal government. I think it would be a game change to try to really develop that kind of a multidisciplinary neuroscientific brain power consortium right here in California.
Certainly the Brain Technology and Innovation Park is something that's going to foster and forward science in general. It's really several $1 billion dedicated to neuroscience. That's going to be inclusive of putting money towards things like Alzheimer's, multiple sclerosis, Parkinson's disease, and also stem cell research. Those are well-needed things in the complexity of what we're trying to fight, particularly those neurogenetic diseases.
So what I like to see is to see more successful story of translating all this discovery into actual clinical setting, and then try to use this method or discovery into actual practice.
Why neurotech? Because neurotechnology is an emerging field, like AI. Years ago, you would hear about augmented reality and virtual reality. That was a great story about new advancement in science. Now you're hearing about AI, machine learning, and supercomputing. The next generation of technology will be neurotech. Your car will be working based on your thoughts. The technologies that we'll be having is going to be basically work off of your neuronal signaling. Neurotechnology is a great field that's going to be revolutionizing our living.
So with that, I would like to go through a couple of slides here, which focus on the financial cost and human cost of neurological disorders to the world economy. You can just see that there are 1.5 million neurotrauma per year reported in the US, and the cost is staggering. It's in billions of dollars. And Alzheimer alone costs US economy about $200 billion per year. So, so that's how the Society for Brain Mapping and Therapeutics and the Brain Mapping Foundation team up and supported California Proposition 14, which is $5.5 billion in stem cell, $1.5 billion for neurotechnology developments, and engaged the partnership and global partnership through Neuroscience 20 of the G20 Summit. So we have created this ecosystem of basically international partners, national labs, even service providers, accountant, law firms, and so on, and bring investors, private equity funds, private offices, angel investors, impact investors, and philanthropists to basically fast track therapeutics, and we welcome your participation as a fine Iranian group in this ecosystem. So when we are talking about neurotechnologies, I would like to just give you some examples of what are we really talking about here. We understand the definition of brain mapping. We understand what the nanotechnologies are doing, what the policies are, but what is this going to be doing for me as a patient or as a scientist? And I think if you take a look at this chart, you'll see, I would like you to pay attention to 3 wavelengths here in ultraviolet imaging, 10 to 400 nanometer, and that's basically ultraviolet imaging, and infrared, and also microwave, because I'm going to show you how neurotechnologies can actually revolutionize the way that we actually treat devastating diseases such as brain cancer. In this case, we designed a device to microwave brain cancer. And so you can see this device, and it was patented and got an FDA approval. So I have a short video here for you.
All right, this is a device, microwave infection device that we have in Sinai. That is microwave chokehold, and to create actually a lesion inside the point. The device is actually controlled by the computer, any laptop, and the plan is that at the time of a biopsy, we basically put the biopsy needle out and microwave ablation and the ablation.
Well, as simple as that, but it took us about 15 to 20 years to get it to this point. So, and the point here is that the Brain Technology Innovation Park fast-tracked that. Another example of this is the use of carbon nanotube, as Dr. Barzagara mentioned. I work with NASA using their carbon nanotube that they use in shuttle and functionalize it with sulfur at the middle, and try to download siRNA and DNA to these carbon nanotube, which the ratio was 1:1, could be picked up by immune system of the brain macrophages. And these are the human macrophages that they are picking up the red dots that are carbon nanotubes. So these red dots go to inside of these cells, basically release the cytokines that are inside the carbon nanotubes, activate them to basically attack brain cancer. Same experiment was actually applied in vivo. That was in vitro outside the body. This is inside the body, and you can see the blue cells are the cancer cells. The red dots are multi-wall carbon nanotubes, and the green ones are macrophages. So basically, you can see macrophages attacking brain cancer. Other applications of nanotechnology in neuroscience is the use of AC magnetic field stimulated nanoelectroporation of the magnetoelectric nanodrug carriers inside the CNS. So basically, the short of that is that how do you actually insert a drug into a cell and track them? So in this case, we wanted to track stem cells and put nanoparticles inside the stem cell and injected that in stem cell to mice and also in baboons. And you could see actually, you could track these with MRI and see where these stem cells are going. So that's kind of a holy grail of cellular therapeutics right now. How do you actually monitor stem cell therapy? Next generation of nanoparticles will be used in the traumatic brain injury. In this case, it's a basically nanoprodrug. It's a combination of nano platforms with ibuprofen, which is anti-inflammatory, and alpha tocopherol, which is oxidative agent, which is vitamin A. Basically combined together, this could go to the area of injury and help the patient. You can also tag this with gadolinium. So this nanoparticles could actually be used for traumatic brain injury. In this case, imagine a patient who are having a traumatic brain injury due to a car accident, get a bolus of nanodrug by the paramedics at the time of injury, and this nanodrug will reduce inflammation, increase oxygenation, expand that 1 hour golden hour for patients to be treated for traumatic brain injury. So this could be also used for Alzheimer's disease and stroke and for brain cancer, which are currently working on it. The next generation of nanotechnologies are nanofilms. So in this case, we actually use, as Dr. Vazgar mentioned, we use carbon nanofilms to basically create a mesh and trap compounds and get the signal. In this case, NASA used this in International Space Center to monitor the air quality. We use it to sniff brain cancer and skin cancer, and we showed that this technology could actually sniff cancer, and we received a NASA award. We talked about neurophotonics and how we can actually use multispectral imaging for detecting cancer. As Dr. Vazgar mentioned, again, I was a NASA visiting scientist. We use their technologies, imaging technologies that they use to detect galaxies and supernovas to detect brain cancer. In this case, this is a real-time, basically, brain surgery on a patient with metastatic melanoma, skin cancer to the brain. And the same procedure you will see in real time in infrared. And both of these are published data. So you could see this, that we are basically taking out the tumor here. So the tumor is out here.
My goodness.
And you can see the tumor will be shown in the petri dish. This tumor, there's no blood vessels attached to it, but it's hyperactive because of the metabolic activities. So this, with the same naked eye, you would think that, okay, well, I took everything out, but as you can see, there was some residual. So it's kind of a game-changing technologies that we are introducing to neurosurgery. And this is another technology that is not ours, but I wanted to show it to you. This is a virtual reality for neurosurgery. You could actually walk through the brain and see where the tumor is. The blue area is a tumor, is a acoustic neuroma. So that's really real-time brain mapping, as you can see, using photonics and augmented reality and virtual reality. So, the next generation of technology, neurotechnologies in AI neurotech, we have integrated all of this and basically spun off a company called Smart Microscopy, which was in my first slide. So we brought augmented reality, neurophotonics, and all that, we use fluorophores that are existing in the cancer. These are compounds that have a certain spectral imaging signature, so you can actually differentiate between normal cells and brain tumor cells. And these are published in reputable journals such as Neurophotonics. Yeah, so this new generation of AI machine learning is coming up, and how do you actually integrate them with the different platform, from the genetics to digital biomarkers, microfluidics, and the patient records, can actually give you a great assessment for different neurological disorders, multiple sclerosis, tumor, dementia, stroke, and so on. So, we could use different modalities to better diagnose and treat patients. Again, this is a multispectral imaging. You can see, basically with the AI machine learning, you can have a better algorithm to pinpoint these tumors. So this is a diffusion tensor imaging you can see in the Alzheimer patients, and you can see the different pathways of the brain, and basically how we could use diffusion tensor imaging to look at the connectomics of the brain, which are the highways of the brain. Let's say from Los Angeles to San Diego, if something is not working, the highway will jammed up. So you see these type of connectomic issues in autism patients, that autistic children or individuals, they have connectomic disease. Okay. So again, another examples of how do you bring photonics and multispectral imaging with predictive modeling here. So this is a glioblastoma multiforme. It's a very difficult, most common and most malignant and deadly brain cancer. Bo Biden died of this. Senator McCain died of this. So if you see, it's very difficult to differentiate where the tumor is, but with multispectral imaging, you can find the tumor. And what we have done, done the mathematical modeling for it. So you can actually see a predictive modeling for the pattern of growth of these tumors. So in the future, the neurotechnologies that you're going to have, it's going to have a better prediction of your health, better personalized treatments, and of course, precision guided therapy. So these are among the final slides. Basically, you see that the future of medicine is also in cellular therapy, but we could actually use this pattern recognition to look at the distribution of the stem cells throughout the tumor or throughout the area that you're basically implanting the tumor, the cells using the nanoparticles. You can 3D reconstruct it and see distribution of cellular therapeutics. So, I mean, we have been working with a series of different companies, as Dr. Barzigar mentioned, Los Alamos National Lab, Lawrence Livermore National Lab, Oak Ridge National Lab, NASA, and private companies like IBM Watson, AI Gnostics, and so on, amongst all amazing collaborators. So in conclusion, I just want to say that the neurotech is focused on the integration of cellular therapeutics with nanotechnology, device AI, and brain mapping, which will revolutionize clinical neuroscience. Scientists should participate also in national debates on science and technology, educate policymakers and about science and technology and issues. That's why we do the policy forum, but also you know, discovery and innovation and pioneering work cannot happen in a vacuum. It has to be in collaboration and be supported by public. So I know that I'm speaking to a esteemed group of Iranians who are super accomplished here. I would like to invite you to be an investor, donor, or participate in any of our activities, including Brain Technology Innovation Park. And again, I would like to thank the POOIA organization, board of directors, donors who are supporting your group for this immense honor and opportunity to present before you. Thank you.